Okay, so let's take a look at your page 18. This is really the only Simpson's paradox problem that you are practicing, so we need to make sure that you are good on this. So first of all, Part A asks you to make a two-way table to combine together the professional schools. Okay, so we want to combine together. So then what I did was I took business and law school male admittances, and I made that number 490. And then I, of course, added these two cells together. 120 plus 90 is 210, and so on. I did that for all four cells. So that is if you combined across the business and the law school, then there is the total admittances for the Wabash Tech Professional School. All right, so then the question says, does the Upper Wabash Tech's professional school admit a higher percent of male applicants than female applicants? So what I did was I first totaled up these amounts. So I added 490 plus 210 to see that there were a total of 700 males admitted. So then if I take the admittances, then of course if I did 490 divided by 700, then I got 70% of the males that applied are admitted. And overall I get 280 out of all of the females. There were 500 total admitted applications for the women, and that was 56%. So I can see that overall there was a higher percent of admittances for the males. Now, then the next section tells you to do them separately. And so that comes from up here in the business school. So I did the same thing. I added together 420 plus 120 to get 600. And then I did the admittances. That would, for the males, that's 480 divided by 600, and that's how I got 80%. And for the females, I got 180 divided by the total of 200, and that was 90%. So if I look individually at the business school, who did better? Females. Okay, if I look individually, the same thing over here at the law school. 10 out of 100 is 10% of the males got admitted, and 100 out of 300 total, 33 1/3% of the female admissions female applicants got admitted. So again, for this one, females. So individually, they both favor females. So the conclusion you make from the separate groups was different when combined. So they combine together across those two categories. Explain carefully, as if speaking to a skeptical reporter, how it can happen that it appears to favor males when each school individually favors females, while the business and law categories were totaled together by adding the fractions incorrectly. And so since they added across the categories incorrectly by not averaging the percentages properly, then that gave the change in the conclusion you make from the separate groups. And again, that doesn't happen all the time, but it did in this case. All right, your next page, page 19, looks like this. So your fractions should go in this direction. Male is the male versus female. This is the direction that your fractions should go. And so here is your... in order to determine independence, you have to check the conditional and can compare it to the marginal. So I did that. I can tell I'm comparing these two conditionals to the marginal. And I can tell that they are different. I can tell females own SUVs at a much higher rate than overall. And definitely also here, males and females, definitely different on the sports car realm. So they are not independent. The fact that you're a male or female changes the rate at which you own an SUV or a sports car. And then, as the AP exam would want you to do, you make a statement for both categories. You could say, SUV is owned at a higher rate by females, and sports cars are owned at a higher rate by males. Now, this last one, this was a very interesting one, how to do. So let me point out to you the numbers that were given to you were these ones that were highlighted. Okay. So what happens is you have to be able to take this information that the variables are independent. So if the variables are independent, then the fact that you're one thing does not change the rate. So once I get the rate, then I can use that common rate and then I can apply it to the other areas. So what that says is, what I first did was I took this 220. Okay, so I took, I first figured out this 160 here because I knew that 380 minus 220 says there's 160 in that category, okay? And then, because your male and female, this is the driver, this direction, okay? So I know I'm going to go this way in my fractions. So then I know that 66 divided by 220 is a rate of 30%. Well, then I say, okay, what number over 160 will give me 30%? Or in my calculator, I would have said 160 times 30%, and that's what gave me 48. And that's how I got 48 right here. Okay? And then same thing with this 114. So I would say, okay, I need 380 times 30%, and that's how I get 48. And so then that right there is how I got 114, sorry. That's how I get 114. Okay? So then that means these are all happening at a rate of the master's and PhD degrees, 30%. Okay? Because those are independent of the gender. All right, and then I just follow that same trend with the others. This is my starting point, so I know 121 out of 220 is 55%. So once I know that's 55%, the other two have to be 55%, and then I can just figure out what those are. Once you finish with 2 of the 3 categories, you could just subtract, but you could also figure it out the same way. I know 33 out of 220 is 15%, so all 3 of these categories have to be 15% because the variables are independent. So the fact that you are male or female is not changing the rate at which you get a particular type of degree. All right, so that was your page 19. Now we'll move on to your page 20, which is, I think, the one on Titanic. Now, the interesting thing here is you had to get past the fact that all of this extra information about individual men, women, and children, that did not really matter. Okay, so there was a whole lot of information on this, and you had to just kind of sort through it. And so, again, I knew that classification was the driver of the lost and saved. So I went ahead and I said, okay, overall, so I took my total. So this section here, this is how I got marginal. I said 1503 over the total of 2206 and 703 over the total of 2206. That's how I got the marginal distributions. And then the conditional had to be done by class. So see, in essence, my fractions, well, because the totals you could see were over here on the left-hand side. So my first class information was out of a total of 322. Okay, and my second class was out of a total of 277. And third was out of this total of 709, and the crew was out of a total of 898. So there's how you got your percentages. So summarize your findings and determine if independence exists. Be sure to include statistical support. Class and survival on the Titanic are definitely not independent. The fact that you are in one particular class makes it more or less likely for you to survive. For example, And then I gave one specific example. But do remember that if you were on the AP exam, then you would say first class is more likely to survive. And then I would list that amount. And then I would, if it was AP exam, you would list all four, a statistic from all four categories. All right. And then here's your page 21. This first one, of course, violates the area principle because they all have the same amount of fruit, but they look like they have different amounts. And then here, this is the same idea over and over again. Your fractions should be going left to right because of the gender is the one that is the explanatory variable. So your denominators are down here, the 760, the 440, and the 1200. So for marginal, your denominators were your 1200, okay? And then for your other ones, the conditional, you had the male denominators were 440, and your female denominators were 760, okay? And so then, of course, you compare these conditional to the marginal. So, gender and body image are not independent. If you are a male, you are more likely to think that you are underweight than overall. That was just one example, but you could give a whole lot. And if it was AP, then you would. All right, so there's your problems for 18 through 21.